Hi everyone. In this series, we're going to be looking at the Wassce 2008 May-June General Mathematics Past Question. Today, we are going to be looking at just question 1. The first question says, if x ratio y equals to 2 ratio 3, evaluate this expression right here. Okay, the first thing a lot of people would want to do is to make x to be equals to 2 and y to be equals to 3. And no, you cannot do that. You cannot do that. That is wrong. That is wrong. Okay? But for you to be able to do this correctly, all you have to do is you have to first of all recognize that this is a ratio, x ratio y, which you can rewrite to be x over y equals to 2 ratio 3, which you can rewrite as 2 over 3. Okay? So now to do this, make x the subject of the formula right here. So in that case, I can cross multiply. I can make y to go to the other side. So in that case, I will have x equals to y times 2. That is 2y. Then over 3. So in this case, I've been able to make x the subject of the formula. So x now is 2y over 3. So all I have to do now is to substitute 2y over 3 for x in this expression. So that means wherever I see x, I need to insert 2y over 3. So let us do that. So this is x squared. So I will make it 2y over 3, right? Open bracket squared, okay? Minus, so you have open and close your bracket squared, y squared, right? Over, this is y squared plus x squared. So instead of having x, you're going to have 2y over 3. So I have 2y over 3. And remember, there is a square here. So you put that square. Make sure you don't forget the square sign. Otherwise, you're going to be wrong in your final answer. Okay? So now let us break this out. 2y over 3 squared. That means you need to square everything. So 2y squared is 4y squared. 4y squared over 3 squared is 3 times 3, 9, minus y squared. Okay? Now that is the numerator side of the fraction. I can do this, put all this in bracket, and then this is the division sign. I can have this divided by, okay? So I'm trying to make life easy right here for myself by saying this is division sign. I put a division sign, okay? And then I solve the denominator. So this is y squared, okay, plus 2y squared is going to be 4y squared, because 2 squared is 4, then you have y squared. 4y squared over 3 squared is 3 times 3, that is 9. Okay, very good, guys. Very good. And since this is my denominator, I can do this. Okay. Now, let us break down this side right here. This is y squared, which I can take to be y squared over 1. So let us break this down, this fraction down. This is subtraction of fraction. LCM of 9 and 1 is 9. Okay. So I can say 9 in 9 is 1. 1 times 4y squared is 4y squared minus 1 in 9 is 9. 9 times y squared is 9y squared. Okay, this is still my numerator. Okay, I have this as my division sign. So we are trying to take it easy right here. Also, y squared right here also means y squared over 1. So I can do this. LCM of 1 and 9 is also 9. 1 in 9 is 9. 9 times y squared is 9y squared. Plus 9 in 9 is 1. 1 times 4y squared is 4y squared. Okay. Now I've turned this to one fraction and this to one fraction. Okay. So now let us go ahead in solving this problem set. So if you take a look at this, 4y squared minus 9y squared, these are like terms. Okay, so that's going to give us minus 5y squared over 9. Okay, remember we still have the division sign right here. I say division, that's divided by 9y squared plus 4y squared. That is 13y squared. 13y squared over 9. Very good. Interesting, guys. Interesting. Okay. Now, if you take a look at this right now, this is division of fraction. All we have to do now is to change this to multiplication sign, and then you invert 13y squared over 9. For a review of that, you can check one of our videos. Okay, so now I have minus 5y squared over 9. Okay, this changes to multiplication, and then I invert this to be 9 over 13y squared. Okay, now if you take a look at this very well, you realize 9 can divide. 9 here 1, 9 in 9 is 1. Y squared can also cancel y squared. Y squared in 1, y squared in y squared is 1. Y squared in y squared is 1. That cancels, right? So if you take a look, you realize that nothing can divide anymore, right? So in that case, this is minus 5. Minus 5 times 1, that is minus 5. Okay, and what do we have right here? 13. So 1 times 13 is 13. So my final answer is minus 5 over 13. Okay, that is my final answer, and this is a proper fraction. A proper fraction. All right, guys, I will encourage you to go back, look at it very well, to ensure that you really understand this problem set and how we have been able to solve it. Now let us take a look at the second problem we are going to be solving right here. The question says, a man on the same level ground with a tree stands at a distance of 12.82 meters away from the foot of the tree. To solve this type of problem, you have to draw the diagram out. But let's continue with the question right now. Then it says, he observes the angle of elevation. Take note, angle of elevation. So what that tells me is the man looks up, elevation, to elevate. The man looks up. He said angle of elevation of the top of the tree as 52 degrees. This is 52 degrees. If the man is 1.24 meters tall, calculate correct to 2 decimal places the height of the tree. So now you need to imagine yourself looking at the top of a tree. And because it says elevation, that means for the man to look at the top of the tree, that tells me that the tree is taller than the man. So now what do? You can solve this type of problem this way. I can say this is the man right here. Okay. I can say this is the ground level. And then I can say this is the tree. Because the man is going to look up to the top of the tree. That tells you that the tree is definitely taller than the man. Okay. Now, a man on the same level ground, this is the man. I will call this place M. That's the man. On the same level ground with a tree. This is the tree. I can call it T. That point T stands at a distance of 12.2 meters. That means this man is standing from here to here is 12.2 meters. Take note of how I'm interpreting this question. That will make it so easy for you guys also. The man stands 12.82 meters away from the foot of the tree. This is the tree. This is the man. The man is standing 12.2 meters away. Now, he observes the angle of elevation of the top of the tree. So that means this is the man's eye level. On a normal day, this is how the man is going to look if he's not looking up. This is his normal eye level. Take note of that. Okay? And then he observes the angle of elevation. So the man observes the angle of elevation of the top of the tree, okay, as 52 degrees. So that means the 52 degrees will be from this line of elevation to his normal level of looking at the tree. If this is the normal level of the eye level of the man, but he is looking up to the top of the tree. So this is going to be your 52 degrees. Okay? Take note again. This is the normal eye level. And he is looking up to the top of the tree. So that means this is your 52 degrees. Now the question says, if the man is 1.24 meters tall, this is the man right here. He is 1.24 meters tall. Now calculate to 2 decimal places the height of the tree. Where is the tree, guys? This is the tree. From here to here is the tree. From here to here is the height of the tree. Okay, So I can say, let the height of the tree be y. Let the height of tree be y. Right? So now this is the height of the tree. This is y. Okay? Also, if you take a look at this very well, you realize that if this side is 1.24 meters, right, this side would also be 1.24 meters high, because this is the man's height. It is also the same thing as this side. You are trying to solve this geometry right now. We are trying to solve this geometry right now. Or other ways you can do this is to, first of all, draw out this diagram. Again, you can redraw this diagram. Okay, now this is the man right here. If I redraw this, I will have something like this. I would have something like this. Okay, I will have something like this. Okay, I have something like this. The normal eye level of the man that we are talking about. Take note that we are not using an actual measurement right here. This is this is just a sketch, 1.24 meters. This is the 52 degrees. This is 12.82 meters. Okay, this is T, this is M, and from here to here we call it Y, right? Now what you can do is 1.24 meters is this place right here, which is also going to be the same thing as this place, because this is the height of the man, which can also translate to this side right here, 1.24 meters. Now what you can do is, the question says to find the height of the tree, which is from here to here, which we have called y. But for you to be able to find the height of the man, the height of the tree, which is y, right here, you also need to be able to find this place right here from here to here, because the height of the tree should be from here to here plus from here to here. We already know from here to here to be 1.24 meters, because that also translates to the height of the man. So now what we need to find is from here to here, which I can call A. I can call A. Also, if you look at from here to here, the distance of the man to the foot of the tree is 12.82 meters. That can also translate to this side right here, to this length right here, to this distance. So that means I can redraw this triangle to be able to find A. Okay, so if I redraw this triangle like this, I can redraw this triangle like this. So that way, this is my A. This is the 52 degrees. And this is the 12.82 meters. Okay. Now, if you take a look at this, this is your right angle triangle. Okay. And this is your hypotenuse, which is the longest side. This is your opposite, because wherever the angle you are considering is facing is the opposite. and then the third side is your adjacent. Now in this case we are trying to find A. If you remember your SOHCAHTOA very well, SOHCAHTOA, this means sine. So sine equals to opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So if you look at this, we have opposite and adjacent. So in that case, we are going to use this formula right here. So I will have tangent, or you say tan 52 degrees equals to A over 12.82 meters. Okay, we have tan 52 degrees equals to A over 12.82 meters. So now what you will do is, what is tan 52? Tan 52 is 1.2799 equals to A right here over 12.82 meters. Now what do? We will cross multiply to find A, and this also means over 1, right? So if I cross multiply, 1 times A is A, then you also have 1.2799 times 12.82 meters. So that is going to give me approximately 16.41 meters. Okay, now if you take a look at this very well, you've been able to get A right here, which is 16.41 meters. Okay, but if you take note, the question says to find the height of the tree, which is from here to here. Height of the tree, which, if you remember previously, we said let it be y. Remember we said let the height of the tree be y. From here to here is y. Okay, now if that is your y, if from here to here is your y, so what makes up your y, which is the height of the tree? What makes it up is y equals to A plus 1.24 meters. Okay, and what is your y? Y would then give you 16.41 meters, because your A is 16.41 meters plus 1.24 meters, right? So in that case, my final answer is going to give me 17.65 meters. So in that case, the height of the tree is 17.65 meters. So you can conclude by saying, therefore, the height of the tree is 17.65 meters. That is your final answer. All right, guys, I would encourage you to go over this video very well to better understand this fundamental concept right here. These are the two questions for the question 1 of the 2008 Wassce May-June General Mathematics question. Also take note that these diagrams that we have right here, they are not drawn to scale. So take note of that, guys. All right, guys, I'll see you in the next class, where we'll be solving the question 2 of this year's past question. Take care of yourself, guys. Bye.